So our next speaker has been a repeat speaker multiple times, both here and at the meetup. And actually, I first met her at the conference. As soon as I met her, I was like, hey, do you want to speak one time? She's like, no. And then eventually she's become a repeat speaker, speaking so many times. It's really great having her here. And another thing, I've said this about her many times, but we have a little biking group here, and she's also in a bike whip, but it's also great because she's a bike mechanic. And last I heard, she had 12 bikes. I'm trying to aspire to that. I want to get up to 12 one day. It'll take me a long time. But everyone, please give a big warning for our first speaker of the second day, Kat.
Well, I'll start by saying no one actually needs 12 bikes, so I'll admit that. But it's great to be back. I see some familiar faces, some new. So the title of my talk today, I actually won't go into R code, which might be a first for me too, but it's more theoretical and kind of like my own observations on building causal measurement, specifically in industry. And I had a lot of trouble writing this talk because I misspelled causal as casual like so many times, including originally in my proposal to Jared, where I had to like panic and be like, where the program's already printed, because I actually misspelled it as casual, not casual. But thankfully, I think we got it right in time for the programs. So a little about me, as Jared mentioned, I'm a repeat New York R speaker. I started coming to this in 2016. This was back when I worked for a 20,000 person company, and we were fully embedded into teams, and I felt really siloed as a data scientist and just wanted to meet other people like me who worked on similar problems or different problems, but using similar methods. And I've subbed in multiple times now as a backup speaker, so you're welcome, Jared. And yeah, I love coming to these things. I think I took a short break, I guess, during the pandemic for my own sanity, but it's great to be back, and it's great to see you all and just catch up and socialize. So I also mentioned in my last slide that I'm an R Ladies member. R Ladies is a really great group if you're a woman in data science and want to meet and network with other women who also are passionate about R. And just as an overview, when I came in 2016, you can kind of see through the years how much we've grown from 2017 to 2018 to 2019, and we're a little overdue for an in-person photo, but I'm sure the community is even larger today. So I'm really grateful for that. I think something that the R community offers is it's a really inclusive community for learning how to program, for learning about data science, and groups like this also just make it so much easier. So a little more about me. I'm a data science manager currently at Twitter. I have experience at a few different sized companies, so both online and offline companies, or companies, I guess, with both an online and offline presence, and that's kind of important for this talk, so I'll go more into that next. And at various stages, so both early stage, Twitter, of course, is a little larger, or significantly larger, as well as I've also worked for an airline, a gym franchise, in which it's a lot harder to do online experimentation, as well as healthcare and elections, where you might be doing field experiments and not necessarily online controlled experiments. But my talk today is about building causal measurement, and I'll actually be focusing a little bit more on I guess the use case of online controlled experiments, where you do have a platform for running that. Although hopefully some of these findings or reflections might be generalizable to offline experiments as well. So the inspiration for this talk, something that happens when you work for Twitter, is you have a lot of conversations on Twitter, sometimes with the people you work with. So there's really great meme, I don't know if you remember seeing this, but it's Julia Fox kind of saying, something like, I don't want to brag, but like, it's a masterpiece or something like this. And one of the product managers who I work with shared this kind of saying, making a self-deprecating joke about PMs sharing experiment results too early. And I appended to it with some labels, of data science kind of being that she was wearing this crazy dress with like a claw on her neck, of data science kind of stopping PMs from sharing early results. And that's something that we find ourselves doing often. But yeah, all of this is to say experimentation is really core to what data scientists do, and we have a really robust experimentation platform that allows us to run experiments at scale at Twitter, and actually at Codecademy too. We did a fair amount of iterative experimentation. And a lot of our work is to guide people like product managers or engineers on how to interpret and set up experiments. But the inspiration for this talk was really on this reply from another product manager I worked with that said, I don't know much, but one thing I know is if it's not in a causal holdback or holdout, Catherine is not impressed by Q experiments. And I guess the spoiler for this talk is upon reflection, experimentation is complicated, and I actually am impressed. So this is kind of me going into just reflecting on what I've learned in online controlled experiments, particularly with setting up holdouts. And I'll go a little bit more into what I mean when I say a holdout versus an experiment. So part one of this talk is me kind of reflecting on this statement. Experiments alone aren't good enough. So really that's what my coworker was suggesting, right? When you run just short-term experiments, that's not good enough. It's better to also have a holdout. So just as a quick primer, why do we run experiments? And I'll talk about two primary use cases, and they're related but distinct. So the first one is you want to gather data to help make a decision on whether or not you ship something. So typically a company will ship or release a feature if the impact from the experiment is positive, even if the confidence intervals are quite wide. So even if the magnitude is anywhere between like 2 to like 10% or something, well, it's positive enough. The second use case is we want to estimate what the impact would be if we rolled out a change to 100% of the population. So typically when you run an experiment, you're isolating a singular change, rolling it out as one experiment, and you're trying to estimate like what would be the impact if I were to scale this up to maybe hedge your bets, reduce your risk, and so on. So that's kind of an overview of a standard experimentation approach where you test isolated changes one at a time with individual A/B tests. So the life cycle looks something like this. You build something new, you run an experiment, you analyze the results, and you make a decision and you ship it. And you never think about it again. And that's an approach that's commonly used by growth teams that just are making a lot of small changes. They're testing them. So this kind of test and learn or growth team model where they're using experiments to decide what to ship. And when I say experiments, we're typically running these for 1 to 2 weeks on a limited sample size. You don't want to exhaust or run out of people to run experiments on, which has some limitations. So one of the first ones is it doesn't allow us to understand long-term effects. So novelty effects post-launch, that typically happens. People get excited, you launch something new, they're trying it out, they're using it a lot, and maybe over time that peters out. So if you run that for 1 or 2 weeks, you might not be able to observe that effect. I say 1 week because that's kind of the bare minimum of how long you typically want to run an experiment just to observe the seasonal effects throughout the week, but that could be a whole separate talk in terms of best practices for experiments. But anyway, so going back to limitations, the second limitation is it's actually pretty imprecise for measuring impact if you want to know what would happen if we rolled this out to 100%. So if you remember from the previous slide, this was the second use case for why we would want to run experiments in the first place. So why is that? So if any of you have ever run experiments in practice online, even at a place like Twitter, even when you have a lot of traffic, more often than not, your results are not statistically significant. And that can be really hard or really frustrating for trying to decide what to do, especially if your goal is to figure out what things would look like if you rolled out to 100%. So It might be okay for fulfilling that first use case in terms of deciding whether or not you ship something. So if it's not negative, it's positive, it's not risky enough to not ship it. But it really doesn't help you with this if your confidence interval is quite wide. So you might say, well, why don't we just sum up all the experiment results? And you can't actually do that to measure your total combined impact. So if you were to ask most businesses or organizations, they don't really care about the impact of an individual change. They want to know what was your cumulative impact of everything that you did or everything that you changed. And it's a statistical fallacy to actually sum everything up because there's a lack of independence with the experiments you're running. Oftentimes there's variance in the confidence intervals. It's not quite as simple as just summing up the midpoint. So what's the solution? Incremental holdouts are kind of core to what I'm talking about today. And this is kind of like the gold standard of online controlled experiments. So a high-level overview is every quarter or every half, and I'll kind of talk through different cadences you might run and why. You hold out a group of users from all of the features your team is launching. So you're bundling all the changes you made throughout that time frame and holding that back from a group of users. And at the end of the quarter or end of the half, you're comparing metrics from the holdout group to all other users. And you kind of rinse and repeat. You bucket a new, fresh group of users into a new holdout group next quarter, and you kind of repeat the cycle in order to enable regular measurement of the impact that you're making every quarter or every half or whatever desired cadence. And why do we do this? It helps us understand the total impact of everything we launched last quarter, which might be a goal that a lot of organizations would strive for. And it's a little more rigorous. It allows you to observe long-term effects, particularly in lagging metrics like retention. You might not see the results on a short-term experiment, because retention takes a while to materialize in user behavior. And I guess to go back into why it's a gold standard, we're statisticians, right? We love more validation, and it really helps you validate your experiment results even further. So one, it helps you determine whether a positive experiment result was due simply to novelty effects. And two, it helps you potentially identify confounding effects from multiple features being shipped. So something might be positive, but in conjunction with something else, it might cannibalize or wash out those effects. And I guess I'll also say throughout this talk, when I say experiments, I'm typically referring to these short-term 1 to 2 week experiments or A/B tests or multivariate tests, but the key is short-term and measuring potentially one or very few changes. And when I say hold out or hold back, I might use those interchangeably. I'm referring to this, so a bunch of changes bundled together and being held out from a group of users. And I'll go into this next, but something that we run into often is this kind of tension of do we put it in the holdout or do we just run an experiment? So part two is, part one, you can kind of see, I guess, just in summarizing holdouts and experiments, all of this sounds pretty compelling. If you're a statistician, you're like, this sounds great, right? This sounds so promising. Why wouldn't we do this? Everyone should be doing this. So part two is implementing a holdout and what that looks like in practice. So I actually won't go too deep into the engineering platform or architecture itself today. So if you're considering running a holdout, all of this assumes that you probably already have a pretty robust experimentation tool for running experiments at scale. And what does that look like? So on a high level, a holdout is really just a collection of feature switch configurations running together for a longer period of time. So the systems are mechanisms for withholding features, or whether you're running an experiment that's short-term or a holdout which runs for longer, and it's really the same. So I have this meme here where data scientists, we think that functionally, right, A/B tests and holdouts are very different. But if you were to ask a software engineer, they would probably say it's the same thing. To them, right, it's maybe more work, but it's the same ask. So here's what a sample holdout schedule might look like. So in practice, here's when you implement it, it looks something like this. And this is actually an example from Hulu. I thought this was a cool public blog from them about implementing holdouts at Hulu and Disney streaming. I credited down there so you can take a look. But this is what it would look like if you were to run this in a quarterly period. Here is a different example where you might run it by half or 6-month cadence. And I'll talk more about when you might decide to run at various cadences. But so here you have a holdback that's running or holdout that's running for 12 months. And there's a warm-up period. And during the warm-up period, we're bucketing or we're enrolling users into the holdout. We're observing their behavior, but we're not reporting our results yet. Or the results are baking, some PMs will say. The reporting period is when we're actually able to evaluate and report on the results. And you're kind of cycling through this over time. So, all right. So I mentioned choosing an appropriate time frame. So really what you want to decide is how long to run your holdout for. So you don't want it to be so long that it becomes too costly to maintain. And negative to user experience. So you don't want to be holding out features or putting users in a version of your application from like 2 years ago. But not so short that you can't observe the long-term impact, because really that's what you're trying to do, understand the long-term impact on metrics. So how does this work? So each holdout runs for 12 months. It's split into 2 halves. The first 6 months is your warm-up period, and the second 6 months is the reporting period. So at any given time, each engineering or product team is maintaining both holdouts in parallel, one in warm-up and one in reporting. And you'll run these for 12 months total. And at the end of 12 months, it's important that you retire the holdout and release users to the production experience, just to not keep them in this really old version of whatever you used to run, which might be slower or be missing a lot of desirable features or whatnot. So lessons learned. So I kind of went over a high-level overview. If you've done this, maybe you're like, this is hard, this seems costly. If you haven't done this or you're new to this, it might seem a little simple. But the biggest lesson that I learned is actually, and this is actually referenced also in that Hulu article, and actually by a lot of, there was this paper from an online controlled experiment summit, where they got a lot of different companies together, and one of the biggest findings is, a lot of the hard part is not the data science, it's the engineering. So this option, running a holdout, usually has a really expensive engineering cost. So your development team is maintaining a code fork that's not updated for a really long time, and that gets really messy. So as a data scientist, I'm not the person maintaining multiple code paths for a year-old version of the app. I'm not dealing with the tech debt. I might see it tangentially, but I'm not directly doing it oftentimes. So I don't directly see or work on the investment that goes into this by development teams. And that was something that you hear a lot from engineering teams. So what do we do about this? I think the things that you need to build are, again, focusing on your experimentation platform and making that better. So some of the pain points and solutions that we identified are, number one, it sometimes takes a lot of time or effort to implement experiments. So you really want to reduce the amount of time or effort it takes to actually setting that up. Two, you want to make it easier. I guess it's hard to ever make it easy, but you want to make it easier to maintain multiple code paths, because again, you need to support both the old and new version of the feature for a pretty long time. And three, you want some level of automation. So something that you hear from teams doing this for the first time is there's a lot of manual or repetitive work, and anytime you do that, that can introduce bugs or mistakes. And when you're adding these feature switches and logic constantly to multiple holdouts, it can cause a lot of issues that you might not anticipate. So you want some level of automation there, hopefully. And it takes a while to build that pattern and behavior so you can figure out what to automate. Again, that could be a whole other talk, so I won't go into too much into that today, but there's so many other things I could have covered, but I guess one other thing is app latency can also become an issue. So if a lot of the code is invisible, but it's still there. So it can boggle down your app, it can still cause a negative user experience, and it's a lot of bloat. So lesson 2, getting people to follow a new process is really, really challenging. So I say this about a lot of things, but a lot of problems are actually people and process problems, and not just technical problems. So as the saying goes, it's like herding cats. I have a lot of cats. If you also have cats, you know what I mean by this. So when you have an organization that's like thousands of people, it becomes infinitely harder to scale knowledge and to get teams to follow a new protocol. So how do we make this better? So not having organizational buy-in is a non-starter. So I have that as the first thing you really need to do. So you want to understand, as with most data requests, it's, why are we even doing this? So it's expensive to build this. What are we using it for? So some organizations might evaluate teams based on their collective performance using these holdouts, and that might provide some incentive from leadership or from top down to actually maintain this or to actually work on this. Some organizations make it really clear that rigorous learning is a priority, and that you want to validate your experiment results a little bit further to make sure people are choosing experiment results by running a lot of things. I mentioned growth teams or growth hacking, right? If you try to sum up your experiment results, you might be over-exaggerating what the impact is. But again, your organization needs to make it clear that they see the value in this and make it clear to teams that they should be working on this and why. The second thing you need is hopefully teams are a little more mature and well-oiled and already following some shared set of principles or processes so that step 3, when you try to adopt a feature launch protocol with specific guidelines on how to actually configure features into a holdout, you want to make your engineering requirements really clear. It doesn't feel so foreign, right? They already have a shared language, shared protocols. This is just another thing. Similarly, you want to maintain documentation on what features are included in the holdout. And you want to do this for context and for visibility when someone's trying to interpret what's going on. A holdout, again, if you remember, is a number of changes together at once. So if you're not documenting that, it might be hard to remember or interpret what's going on there. And lastly, you want to develop a shared framework for analysis and reporting to make sure that you're all kind of consistently looking at this the same way. Lesson 3. I guess one of the things that I arrived at was also, maybe you don't need a holdout, and I'll put yet because I think any company would benefit from it if you can do it. But one of the lessons that I learned is learnings from a few well-run experiments are significantly more valuable than trying to analyze a poorly maintained holdout. So also as a reminder, even a well-maintained holdout, right, doesn't give you a deep understanding that you would gain from running independent experiments because you don't know which specific change is positive or negative. So I would argue that experiments are more valuable than holdouts. And of course, the gold standard is having both in conjunction. But if I were to choose one, don't put the cart before the horse. Focus on getting experiments right first. So here are some signs a team might not be ready to implement a holdout. So I mentioned in lesson 1, if you have engineering bandwidth, maybe there are faster or cheaper ways to get to the measurement that you need. Maybe you don't need to chase precision and kind of go down this rabbit hole, which can be costly. And again, garbage in, garbage out. If you're not maintaining the integrity or quality of your holdout, it's not that useful. A second sign might be your engineers or your development team is inexperienced with experiments to begin with. So if they have a hard time running just a standard A/B test, you want to get them familiar with running and maintaining shorter or smaller experiments to start and getting that right before they graduate to running holdouts. And lastly, one thing that ties back to that schedule is maybe your teams aren't shipping fast enough or at a regular enough cadence. So again, developing those patterns to require a holdout. So if you're not doing that, then you're probably better off running experiments as needed or until you develop some sort of regularity. Same can be said for impacting the same set of metrics consistently. If all of your experiments are impacting different metrics, if you roll them all into a holdout, you're probably not going to see much value from that. So I talked about all these lessons learned, but would I do it again? Yes. It's great when it works. So I think for more mature teams who have all the ingredients to actually implement and maintain a holdout, it does what it promises. So in this new cycle, you run a standard experiment for 1 or 2 weeks as you previously would. Then you would, if it's positive, launch it to all users, but withhold the change from the holdout. And as promised, it gives you more time to observe the impact on lagging metrics, like retention. You ideally get past that novelty window or novelty effect that you see with shorter-term experiments and understand the true impact. And it provides additional validation to help you actually understand compounding or interaction effects from multiple launches. And again, this diagram's from a blog post, which is pretty good for looking at another example at Hulu and Disney. So I guess to return back to the original thesis or impetus for this talk, or interaction I had with my team, while having a holdout might be the gold standard of online experimentation, they're not always necessary. They're not always possible when you're trying to build causal measurement. And actually, I am pretty impressed by some teams that run experiments, because experimentation as a whole is really hard. And just because you have this tool or method at your disposal, it doesn't mean you should always use it. So here are some additional resources. I reference a few of these. Ronnie Kohavi has a lot of really good literature on practical considerations for online controlled experiments. I cite this book quite a lot, Trustworthy Online Controlled Experiments. It's probably the best resource I've seen for industry examples. I mentioned this blog post from Hulu. And Sean Taylor's talk, he gave one pretty recently about experimentation and causal measurement that was pretty useful as well. And yeah, that's all for me. I hope this was useful, and I'm a little over time, but thank you, and see you all soon.
All right, thank you.